Hi, it's Jim from the maverickstar Observatory. I'm going to answer a few questions in here, like how long do we have before something very significant that takes place? What will happen and why? And how will it be affecting ourselves at that time? Before I do, I want to say big thanks to those few people over the last few days that have come forward and give us a bit of support on PayPal. And big thanks to the patrons. As always, thank you for sticking with me. And guys, at the end of the day, we need support. We're a publicly funded observatory, and without privately funds, we can't do what we're doing. And hopefully you'll agree, we don't just talk about these issues. We use scientific data. We collect data from all around the world now with our magnetometers, and we've also got the TriMag and the magnetosphere sensor here in the UK. And on top of that, our observatory has muon detectors, which will be going out into the field hopefully next month at some point. So if you can help support us a little bit, guys. I will say this: it is one of the worst times of the year for ourselves at the observatory with funding, because everybody else has their own things to do at this time of the year, and that comes at a cost. So I do appreciate that, but guys, at the end of the day, if you can give us a bit of support, that'll be great at this time. So let's just first of all have a look at how close we are to the 40-degree mark, and why is it important in the first place. Well, some of you may remember me doing some experiments with magnets, and what happens to compass needles when they influenced by magnetic field. Around about 40 degrees, the magnetic field or the compass needle starts to wobble, and that's because it's leaving the strong field lines and it's now entering the weak field lines, and it's at that 40-degree mark where the compass needle flips right over. So that's why we have put this 40-degree mark. What that line next to the 40-degree mark, the white one, represents is 40 degrees movement from the time it first started migrating back in the early 1900s. And all these little pins that we've put in there are from organisations. They're from ourselves. We've got pins that the Geological Survey have pinned and pegged the magnetic North Pole at, and we've also got ours, as you know, that we have arrived from the data that we collect with the TriMag. So just to measure in miles how far that 40 degree is off, you can see it is around about 178 miles. So it's about 178 miles away, as you can see, and we know that on average it travels every month around about 3.7 miles per month. Sometimes a little bit more, sometimes a little bit less, but that gives us a time period where the magnetic North Pole should reach the 40 degrees mark of about 3.9 years. And that's not a long time. It's also coincidentally around about the same time from one of our magnetometers that if we gauge how much the magnetosphere or the intensity in that region of where our magnetometer is has lost in 5 months 7% of the Strohnfall 4 microteslas. It also puts it at a total loss of 58% in 4 years, and I think it was about 98% in 7 years. So we're saying, so long as things maintain the speeds and it doesn't go any quicker, and it has done in the past, so we can't outrule that that will be the case. And if that is the case, it could be less than 4 years before the magnetic poles on this earth reverse. So that hopefully answers the question for you, how long we've got before the event starts to happen, this reversal starts to take place. It is 3.9 years away, or thereabouts. So to answer the next question, what will happen and why? Well, what is happening as a result of the poles is already noticeable. I've said it for many years that I don't believe that the magnetic poles are on our northern and southern hemispheres just by coincidence, and they're also in the regions where it's colder. and I also believe that they could have also influence on the rotational axis, but you know, that is speculation, or just a theory of mine, because I don't believe that all these things are there, you know, just by simple coincidence. And you know, we have seen some movement recently with the Canadian pole, and as you can see from here, what used to be two evenly spaced temperature regions, where the highest intensity is of the magnetic poles over the northern hemisphere, you can see just where Canada is, there is that little piece missing off there now at the left hand edge. And I believe that that is because of the weakening of the you know, the region in Canada. If you look at the video at the bottom of the screen, first of all, like I say, I don't think it's by any coincidence we get this very similar shape. Where the highest intensity is one of the coldest regions on our planet, as you can see, and where the lowest intensity is, it's also the you know, milder weather is experienced in these regions. We can see on this part, on the top left disc of the lower screen, we can see that the actual redness of that region, or the intensity over a period of probably 8 years, has rapidly dropped off. And I believe that that's why when we look at the temperature chart on North Skull today, we see that there is a piece missing off of the temperature in those plumes, and that's why we don't see like we used to do perhaps a couple of years ago. And I have got some stills of the temperature over the northern hemisphere back at that time, where you know, it is mirroring what we're seeing in this magnetic anomaly chart down the bottom there. So I don't think it's a coincidence, guys, that we have a magnetic pattern the same as we do temperature patterns. And if that is the case, then what we should have take place over Canada in the years to come is, you know, I know it's going to sound crazy, but less Arctic temperatures, especially towards, you know, the further north you go in the Arctic regions. One of the things that could slow it down from being that, you know, from making that the case, is one of the results of weakening magnetosphere as these poles go into a reversal on the planet, is it affects the jet streams. And of course this in turn brings, you know, those Arctic temperatures down when the jet stream's low. If I just put the jet streams on so that you get a visual of what's taking place on our Earth with regards to the jet streams, you'll see what I'm talking about. So America, as you know, recently has suffered a lot of Arctic temperatures, and that is because the jet stream has been very low hanging in that region where there's been a lot of snow deposited. At the moment over in Australia, if I'd have showed you this morning, Australia was glowing red on this North Skull with regards to the temperature, and looked to appear to be one of the hottest continents on our Earth. And you know, as a result of the jet stream being really low for a period of time, it has you know, had a lot more warmer and less rain in that region. But looking at this, if this little jet stream here does carry over the continent of Australia, it could be, you know, a couple of days before they start to get some rain around the central regions. But we'll just have to wait and see how that goes. So to answer the question, what will happen and why will that be the case, it's a case of, you know, looking at the condition of our jet streams right now and what's caused them to be like this. Because normally we would have a polar jet stream at 60 degrees over the northern hemisphere, and we'd have a subtropical around 30 degrees, and it'd be the same for the southern hemisphere as well. As you can see, we have one very big distinctive jet stream, in some cases thousands of miles wide. And what's been happening is the water vapour has been going into these jet streams, it's been making them more lazy, so the troughs and peaks are further spread out, and as a result of more cosmic radiation, we end up with more seeding. And you know, if the magnetosphere weakens more, we end up with more cosmic radiation, collisions in the atmosphere, and muons on the ground. But how it affects us is in a multitude of ways you're already seeing the effects, and we haven't even entered the rapid part of the reversal yet. And as a result of that, over the last 20 years we've seen these jet streams deliver some really shocking climates in regions such as flash floods, more snow than what the northern hemispheres usually get, but also it's what happens in relationship to the cosmic radiation when it gets down to the ground levels, and that causes more cancers. It also causes cardiac arrhythmias problems, and if our magnetosphere is going to continue to weaken, then what we will see over the northern and southern hemispheres is more fracturing of these jet streams and more climate chaos in these regions. And what we need to remember importantly is what I touched on yesterday. If we now as a modern civilization have moved and migrated to parts of this world which was pretty much uninhabitable at some times in our history because of the climate in that part in time. If we look at, like I showed you pictures of Australia, you could see how red the soil was, and also in South Africa, and that's because the bleaching of the sun has oxidized the soil so much it has sent it red. It's okay when you're in a time period where you've got a lot of technology to manage imports and exports, so if you have crop failures and things like this, you can deal with these issues of losing crops. But if this continues and other parts of the world become affected by the same scenarios, and it could be different. I mean, we're seeing two different scenarios play out right now. In America we're getting these Arctic blasts, and in Australia we're getting these droughts because of the heat. And if it affects other regions on this planet, this is where it starts to affect us. Other than just the risks to cosmic radiation, it starts to threaten our modern civilization. Now, the world governments have raised trillions of pounds, as you know, in carbon taxes, and carbon isn't what drives the climate. It's a trace gas in any case. It's pretty much irrelevant, and I've talked about this almost all week. If we go down to 150 parts per million, we shut down the growth of all the diversity of trees, plants, foliage, shrubs, you name it. If we increase carbon, we actually make the planet greener as a result of that. But the problem is that we are being told by these governments that it's CO2 driving climate, and it clearly isn't. They have overlooked the fact that we are in a magnetic reversal, and on top of that we're also going deeper into a grand solar minimum where the sunspots are dropping off, and we're at the moment seeing the sun with no spots for the longest period of time for ages. And as a result of that, we are again having a problem with cosmic radiation, because the sun's activity usually inflates like a bubble over our solar system called the heliosphere, and as a result pushes away a lot of that cosmic radiation. So we've got cosmic radiation inbound from a grand solar minimum, having low solar output. We've also got an ever increasing risk of more cosmic radiation as a result of a weakened magnetosphere due to the poles reversing on this planet. The muon count rate has gone down a little bit from about a week and a half ago, from 610 to 540 muons per square meter per hour. But I still think that is an incredible lot of muon radiation, if you want to look at it like that. Especially when your presence probably takes up almost 1 square meter of Earth on this planet. So when you're standing there right now, you're probably having around about 500 or so muons go speeding through your body, and because muons are ions, it is an ionization radiation, and that's why we are going to be looking more deeply into where the low regions of magnetic intensity are and where the high regions of magnetic intensity is, as to how much protection you get in those regions, because Brazil is in the South Atlantic anomaly right now, and that is one of the lowest regions on our planet. And I bet, and I can only prove this when I get them, the muon detectors out to there, and in one of the highest regions on our planet, again, we can then say for sure that that is the case. But this could give us a heads up as to where's probably best to select if you are in the mindset that you're prepared to migrate to avoid future problems. But one thing that is going to get us all eventually is, if this climatic changes keep taking place and delivering chaos in these continents where we're wiping out crops, and Australia, I think good 45% of its corn this year has been destroyed by drought. And I know from people that I speak to in Australia at the moment, I know that they have started to use, I believe, some of these desalination plants to start producing water from seawater. So, they're going to be, this is it, the game's really starting now. We are already resorting to, extraordinary circumstances in order to keep our colonies on this planet in the regions to date. If these climatic changes continue to worsen, and they will, we haven't reached the equilibrium of the worst part yet, then it's only going to put more and more of these nations at threat as time goes on. And what we have to bear in mind is that we are 7 billion on this planet at the moment, and we're used to having a wide range of products from all over the world. But weakened magnetosphere could allow a reasonable coronal mass ejection to arrive at the Earth's surface, knocking out electrical equipment. And our governments haven't prepared for this. You can't replace all the transformers in a power network overnight. You first of all got to start placing orders, and then the company that you've just give a huge order to has got to order all the equipment but what happens is it's not going to be repaired in 2 weeks, and we know what happens to people being impatient in those 2 weeks. The trouble starts. And we can see this cascade from one country to the next very easily. We are in very vulnerable times as a result of relying so much on technology like we do today. If we go back, to when the Vikings had colonised Greenland, the height of technology at that time, when temperatures started to dip and not favour sustainable living on Greenland, their technology levels was low, whereas ours is very high, and as a result of that, we're more vulnerable than what they were. They would be more likely to last longer, and even though they weren't so technologically advanced as us, they still roughed it out for a good 100 years until the weather peaked a little bit and it got a little bit warmer again, and then it turned after about another 50 or so years. And of course at that point it was time to abandon that continent because it was proving too hard to sustain colonies. Now, it's not unusual for this to be the case. If we look back in our history, we know that the main occupants or residents in Australia were Aborigines. We still have Inuit, Eskimos in Norfolk, Canada, Puffin Island and around those places. But these people have adapted and learned the skills to enable them to, to be sustained in these environments. We simply have not. And we don't even teach our children these days how to light just a simple fire, with rubbing two sticks together, and how to catch your own food. Some kids believe that milk comes from a supermarket and not a cow these days. This is the state of our education system. It's focused too much on improving and making more advanced technologies, and seem to have left the raw skills that we need to survive And the reason for that is because we have took it for granted over the last 100 years that we are invincible now that we have all these mod cons and technology, and it couldn't be any further from the truth. It's made us more vulnerable as a result, and you know, we are now at the precipice of being taught a very serious lesson with regards to that matter. So that is how long we've got, and that is what will happen and why it will happen, and that is how it will affect us. It will affect us with our crops, and it could also take our grid down as a result. And if you avoid those two things, you're also possibly at more risk over the next coming years of getting cancer as a result of cosmic radiation, or having, you know, cardiac arrest through it altering the cardiac arrhythmias of the heart. So those are the real risks involved. And you know, if you want to find out more about this rare anomaly that we're in, and you want to keep track of it, then follow us here on YouTube and on our website poleshiftnews.com. And you know, guys, we are completely public funded on this channel and on our website, and we can only do things when we're funded. It's as simple as that. You know, NASA have the luxury of millions of pounds worth of taxpayers' money. We simply don't. But one thing, as you guys already know, is that I always manage to stretch whatever we get here and make a lot of it, and that's simply because I've got the skills such as programming, electronics engineering to build the equipment, and you know, the time to invest in researching what we've got to date. And you know, we've been very lucky to have a tool like YouTube, which has enabled us to get in touch with people that want to join in on the research, and you know, have put magnetometers in their own properties for us and sent us the data regularly every month. So you know, big thanks to you guys as well. But more importantly, guys, we're in the worst period of funding for ourselves, November, December and January. And you know, I know you get bored of hearing me say this, but you know, we are an observatory funded by the public, and if we don't ask, we simply don't get. So there is a link there if you want to support us, and why not step forward if you haven't already. You know, jump in and help us. You know, we can only you know, answer more of these questions for you guys with, you know, the more data that we collect, and you know, we can only do that if we're funded. But there you go, I'm not going to go on. Have a great day, and I'll catch up with you at some point tomorrow for the last video before the holiday season really begins. So Merry Christmas to you all, and I'll speak to you tomorrow as always. Bye for now.